Thank you very much, AICTE and Skyfi Lab, for providing opportunity to attend a program on machine learning using Python. This video is basically prepared as a part of assignment mentioned in this course on machine learning using Python. So during the entire course, it was described how to use Python for machine learning with one example of prediction of price of house. I am using here Anaconda and this Jupyter notebook, which is installed as a part of Anaconda package. Anaconda is very much useful as we do not require to install all the modules individually using pip command. Otherwise, we need to install all these NumPy, Pandas, Matplotlib individually using pip install command in a Python. But once we install the Anaconda, we do not worry about all these modules separately. All the modules will be available inbuilt. So as a part of assignment, I will be importing certain modules like here I have imported NumPy. Import NumPy as NP, so this is useful for numerical computation. I imported Pandas as PD. This Panda is very much useful for data analysis and processing purpose. Then module Matplotlib. This Matplotlib is a very important module to plot data in a different format. So there are so many plots are available: bar plot, line plot, and etc. etc. Many plotting functions are available in this module. Then one more is matplotlib.animation. This is useful to do animation because we will be using here curve fitting, and we would like to compare how much our predicted value is near to the actual value or target value. So for all this comparison, this is very much useful. Then one more module is a Seaborn module. This Seaborn is providing a statistical data visualization. And then MPL_toolkits. This is useful for scattering of different plots. This is basically a 3D scatter plot. So I am importing all these required modules for this assignment. Then actually I tried both data set. One is a California housing data set, and during the training this Boston data set was discussed. So I tried to use all this function which is mentioned in training for the California housing also. So I have done experiment on both, but in this assignment I will be discussing this Boston data set. Then here one more function is a mean squared error. Actually we can write our own function to calculate the mean square error, but I am using this ready-made function which is available in this sklearn module. Then one more module is a train, test and split module. So basically whatever the data set we have to divide that entire data set into some data set we have to keep reserve for a training purpose. Let us say about 80% of data you have to keep reserve for training purpose, and about 20% of total data you have to keep reserve for testing purpose. People also use training and some data set for validation also. So in that case 70% of data we can use for training, 10% for validation, and remaining 20% is for testing purpose. But we are not using here validation step. We use only data for training and testing purpose. So whatever the data available with us, we will be using 80% of total data for training and remaining 20% of total data for testing purpose. Then before we feed this data to our model for learning purpose, we have to pre-process the data. So there are different ways of pre-processing of the data. Out of that, we use here min-max scalar method. So in which whatever the data we have, all the data will be normalized between 0 to 1. There are other techniques also, like calculating the mean value and then subtracting that mean value from all other values, and then calculate the variance and modify your data in such a way that the mean value of the data will be 0 and variance will be limited to up to 1. But that other techniques we are not using. We will be using here min max scalar, which is very simplest technique we are using in this assignment. Then we also use this ipython.display, which HTML. Basically we will be doing some simulation, and then simulation video if you want to display on the screen, then this is useful. This is the flow chart we will be following. First one is the loading data set. We already load the data set. Actually we will be using here I have done experiment with California housing also, but I am using in this assignment Boston data set. So that Boston data set we are importing here. So we will be loading the data set, then we will pre-process the data. After pre-processing, we will split that data into testing and training set. So there is a ready-made function available to split the data, which will split whatever the data available with us into training and testing. As we discussed, people also use some portion for training, then validation, and then testing. But in this assignment, we will be using only training and testing of data set. Then we have to choose appropriate machine learning algorithm for the training. But in the Skyfi training, the linear regression was discussed. So I will be using the same algorithm here in this assignment. Then we have to train the model, and to train the model, actually we require different functions like gradient descent function, and then we have to calculate mean square error. And initially we will assume some coefficient value. We will calculate the output, and this output will be compared with the target, and mean square error will be calculated. And then using a gradient descent function, we will try to update the coefficient, and we will try to update coefficient in such a way that this error should be minimized. And as and when this error is less than certain threshold value, we will stop our algorithm. So ultimately this is the process of training a model. Predict output based on input testing data, and once that our model is trained, then after we will feed the testing data, and we will check whether predicted output is nearer to the target value or not. So this is how we will write a code in this sequence. So first of all, as I told, that the first step is loading a data set. This is our first step, load data set. So here housing equal to load underscore Boston. This is a function available to load the Boston data set into this housing variable, and then we will print this housing description. So we have a housing data set, and this is actually housing.describe will describe entire data set. So it has a total 506 records, and different attributes it has, like crime, how much crime rate is there in that particular locality, and so many other parameters which will directly affect the price of house, how much this house is old, actually age of that house, how much it is far away from the highways, what is actually tax, property tax, then median value of owner occupied homes in that particular area. So these are all the attributes which will affect the house price directly. So this is the data set available. More details one can get from this particular link. Then whatever the features available in this data, you can grab all these features using this function pd.dataframe. So in that housing.data, and then columns will represent all the features. So housing.feature names which will be given as a columns. So when we print these features, which is actually given with this, whenever we write these features in a Jupyter notebook, and whenever we press alter control, alter enter, then all these features will be displayed. So I have already run this code, so it's available here. All the features are displayed here. As you can see that all the features are arranged in a column way. So all these features are available, and these are the records available with us. So that there are total 0 to 505. So total 506 rows are there, and 13 columns are there in this data set. If you want to display particular features, like in this example features crime, then this will be displayed here. One more function is that here target is equal to pd.dataframe, because ultimately all these features will decide certain house price. So house price is a target for us. So here in this data set we will be setting a target, and then we will print maximum value of target and minimum value of target. So here I am printing here maximum value of target and minimum value of target, and the value displayed here is 50 and 5. So 50 is the maximum price, maybe it must be in lakh, so 50 lakh rupees for a house is the maximum price, 5 lakh is the minimum price. Then we will be concatenating all these features together using concat function, because we want to arrange all the features and target into a single data frame. So to arrange in a single data frame, this is the function utilized. Then we will be using df.describe function. Basically this describe will give you all the statistical overview of your data set. So whatever the how many data sets are there, so count value is given here. So for all the features we are getting here 506, 506, 506 everywhere. The meaning that we do not have any missing data. That means everywhere there is a data. If there is a missing data, particularly let's say in some rows actually text is not mentioned, then you will get here less number. You will not get 506 here. So there is no missing data in this data set. Then the mean value of this crime rate is 3.6. Standard deviation is 8.6. Minimum crime rate is a 0.006320, and these are the percentile. So percentile crime rate. So here 50% crime rate is 0.25. So basically this 0.25 50% percentile means that is median value. Here average value, that is mean value, and median values are different. That means this data is not basically a uniform, uniformly spread across all the records. There are few data sets which are actually somewhat uniform, like for example if you look at here median value is 9.69 about, and mean value is 11.13. so somewhat it is a uniform. So this is how you can all the features can be represented with describe function. Then this is how we would like to calculate the correlation. So you will be using a Pearson method to calculate the correlation available, and then we will be looping through all the features because we want to calculate the correlation for all the features. So using this function for attributes in a list of all features, so it will take features one by one and compute correlation for all the features. And we are interested in absolute correlation. That means we are interested in only we are not worrying about the sign of that, so we use the absolute correlation. And then basically we will be sorting all these correlation from in a descending order. So the sorting basically useful. So that means the highest correlation value will be first, and then after the lowest correlation, and that's how we will sort entire list. Once the list is sorted, what we will do is we will try to plot these correlation values. So what we will do here, we will have an index for the plotting. So basically this index will represent the x-axis, and correlation will be plotted as a y-axis. So if you look at this graph, a plot figure, so this is the figure size. You can change the size by changing this parameter here. This is the width of every bar. 0.5 is the width of every bar. X-axis shows the attributes, that means all the features of the data set. Y-axis gives us the correlation with the target, that means how much that particular feature is affecting the house price. That is represented in y-axis. So if you look at correlation graph, this L-stat parameter or a feature, it is highly correlated with the target, that is house price. That means it is affecting house price much. Then after, the next is RM. So this is actually showing all the correlation. This CHAS doesn't have a much effect on the or not much, but least effect on the house price. So its correlation is less. So this is how we can plot this correlation. The next part is a pre-process the data, that we have to do some normalization. But because there are limitation of video to upload on a YouTube, actually I am dividing this entire assignment into two part. So remaining part, pre-processing training part, we will discuss in part 2 of the videos. I will be preparing another video and I will be uploading that on the YouTube. So I will stop this part 1 here. Remaining part I will discuss in part 2. Thank you very much for your kind attention.